How did Iran manage to hit an American F-35 stealth fighter? Well, in modern warfare, there are primarily two kinds of anti-aircraft missiles: radar-guided and heat-seeking. The F-35 was designed to be practically invisible to long-range radar, but it wasn't built to completely hide from heat-seeking missiles. So how exactly did Iran missile manage to bypass the stealth technology of the US F-35? Well, the secret lies in a major vulnerability, that is its heat signature. Its geometry and radar-absorbent materials make its radar cross-section incredibly small, essentially rendering it invisible to traditional early warning and targeting radars. To give you some context, this is how a plane's radar signature compares to a bird's. But the F-35 is powered by a single Pratt & Whitney F-135 engine, one of the most powerful fighter engines in the world. The F-35 is heavily optimized to defeat radio frequency radar like the billion-dollar S-400 and S-300 missiles. However, stealth does not mean completely invisible. This engine produces a massive heat plume. Instead of using radar, modern air defense networks utilize infrared search and track systems. The answer is this short-range heat-seeking missile like this one. These passive sensors scan the skies for any heat anomalies. Because infrared search and track systems emit no energy themselves, the F-35's radar warning receivers would not alert the pilot that they were being painted by a target lock in the same way a radar lock would. But how did the missile lock, and how did the F-35 use evasive maneuvers? Once an infrared-guided missile is launched, the dynamic of the engagement changes to a race of physics and countermeasures. When the missile's IR seeker head locks onto the massive thermal output of the F-35's engine exhaust. But the detection, the F-35 is equipped with a distributed aperture system, 6 infrared cameras positioned around the aircraft that provide a 360-degree spherical view. The distributed aperture system detects the intense heat signature of the incoming missile's rocket motor and instantly alerts the pilot. To break the lock, the pilot executes high-G evasive maneuvers while simultaneously deploying flares. If the missile tracks the flares but is already within a lethal radius, its proximity fuse will trigger the warhead. The resulting shrapnel and shockwave can cause significant damage to the aircraft's control surfaces, stealth coating, or internal systems without scoring a catastrophic direct hit, which perfectly aligns with reports of the F-35 sustaining damage but safely executing an emergency landing. But what are flares? These pyrotechnic countermeasures are made of magnesium or other combustible metals that burn at temperatures exceeding the aircraft's engine heat. The goal of the flares is to overwhelm or confuse the missile's IR seeker, forcing it to chase the decoy heat sources instead of the jet. But what is Iran's secret weapon? We believe it's the 358 anti-aircraft missile, or the SA-67. The 358 is a unique hybrid between a loitering munition or kamikaze drone and a surface-to-air missile. But how does it work? It flies at slower subsonic speeds and can loiter in a designated airspace in a figure-8 pattern until its optical and infrared sensors detect a target. If a 385 missile or a more advanced high-speed indigenous IR-guided surface-to-air missile was guided by a ground-based IRST network, it could engage the F-35 entirely within the infrared spectrum, bypassing the jet's radar-evading capabilities entirely. This incident challenges the long-held doctrine that fifth-generation fighters can operate with total impunity in contested airspace, highlighting the evolving threat of infrared detection. But it has its advantages, as it cannot hit fighter jets far from its radius of launch system. During Operation Fury, the US has been using F-35s to lead strikes and declared air superiority to hunt for surface-to-air missile and suppress air defenses. Although the US has achieved near-total air superiority, but the war is just entering its most dangerous stage. But here is the problem: Iran is still not out of the fight. If the US owns the sky, why not just send in standard fighters? Because while Iran's main network is shattered, isolated surface-to-air batteries like the S-300 are still hiding in the shadows. For an F-15E Strike Eagle, the legendary bomb truck of the Air Force, one lucky radar lock from a rogue missile is a death sentence. And in a high-stakes conflict, losing a crew and a multi-million-dollar jet to a surviving battery is a risk the Pentagon simply won't take. But how did the US and Israel manage to use F-35 jets to strike Iran while Iranian air defenses were still up and running? To make this happen, they didn't just rely on local land bases. They brought two massive floating cities right to Iran's doorstep. Down in the Arabian Sea, you've got the USS Abraham Lincoln Carrier Strike Group bearing down on the south and east. And over in the eastern Mediterranean, the biggest newest ship USS Gerald R. Ford. While Israeli jets flew all the way across the Middle East to reach Iranian airspace, timing was absolutely critical. The moment those IDF jets reached their marks, the missiles were released. And that brings us to the most terrifying, complicated part of this entire operation, the synchronization. Military planners rely on a tactic called time on target. Look at this map. You have missiles firing from submarines, cruise missiles launching from escort ships, and massive payload drops from stealth bombers. They are all deploying from completely different locations at entirely different times. But here is the genius of it. The US military machine was mathematically choreographed so everything impacted Kairaj, Tehran, Qom, Kermanshah, and Isfahan at the exact same second the Israeli jets dropped their guided bombs. It was designed to be a total systemic shock and explodes at the same time. A move to collapse the regime instantly. When those munitions finally hit, it was pure shock and awe. But why did the Iranian air defenses fail to activate? Well, to put it simply, the US military operates in a completely different league. Using a highly advanced mix of electronic warfare and cyber operations, coordinated from space to the ground, the coalition was able to inject false data directly into Iranian radar screens. Top-tier Iranian air defense systems like their homegrown Baver and their Russian-supplied batteries were absolutely overwhelmed by this electronic assault. But to actually hunt them down, the US set a brilliant trap. They launched hundreds of ABM-160 MALDs, miniature air-launched decoys. To a panicked Iranian radar operator staring at a chaotic screen, these tiny drones look exactly like a massive squadron of A-15s or F-16s screaming toward the capital. With the door kicked wide open, fifth-generation stealth fighters, including both US and Israeli F-35s with possible F-22 Raptors, sliced through the airspace completely undetected. Ultimately, the Iranian air defense network wasn't just suppressed, it was completely dismantled, at least for the time period. Because the Iranian do have a huge firepower. Tehran has fired back. In Operation Truthful Promise 4, a massive wave of missiles and drones just targeted US bases in Israel. Here's the fallout. The UAE's Al Dhafar air base was hit, leaving one dead from shrapnel. In Bahrain, the US Navy's 5th Fleet HQ was directly targeted. Qatar's air defenses successfully wiped out incoming missiles, while Kuwait locked down its entire airspace under heavy fire. Meanwhile, nationwide sirens are blasting across Israel, with massive mid-air interceptions lighting up the skies over Tel Aviv and Jerusalem. But how did Israel manage to fly all the way to Iran? At 9 in the morning, Israel launched more than a dozen aircraft, but it's a complicated process. They have to navigate or entirely bypass the airspace of neighboring countries like Syria and Iraq. To avoid hostile air defenses, defense analysts estimate the actual flight distance to reach central Iran is between 930 and 1,240 miles each way. Although these routes may seem straightforward, they involve complex planning, including calculations for air refueling and coordinating attack aircraft to pass through Jordan, Syria, and Iraq. Israel and US strategy was to attack Iran in 3 waves. The first wave targeted surface air-to-air sites, radar installations, and Iran's air defense headquarters in Tehran, Elam, and Khuzestan. The second wave focused on destroying ballistic missiles, and finally, the third wave targeted military manufacturing industries. Kicking down the door. The attack begins not with manned aircraft, but with robotic precision from the sea. The goal is simple: blind the enemy's eyes, their radars, and silence their voice, their command and control. In the Persian Gulf and the Northern Arabian Sea, Arleigh Burke-class destroyers, ships like the USS Thomas Hudner, receive the launch order. The vertical launch system cells hiss open, and moments later, dozens of Tomahawk land attack missiles erupt from the decks. These missiles fly at subsonic speeds, humming the terrain in what we call nap of the Earth flight to stay below the radar horizon. They are programmed to loiter and strike simultaneously. Their warheads slam into S-300 and S-400 radar sites and command bunkers. They degrade the integrated air defense system, effectively carving out safe corridors for the pilots who are minutes behind them. 30 minutes past each hour, while the Tomahawks are still impacting, the silver bullets of the US Air Force are already deep inside hostile airspace. These are the B-2 Spirit stealth bombers. With the air defense network fractured by Tomahawk cruise missiles, usually fired from destroyers hundreds of miles away, the path is now clear. Now comes the strategic sites like nuclear bunkers, which can be bombed by B-2 Spirit, the tip of the spear. Launching from bases in Jordan and the UAE, squadrons of F-15E Strike Eagles roar into the theater. These are the bomb trucks of the operation. Each F-15 is heavily laden with GDAMs and small-diameter bombs. Interestingly, it can carry up to 19 GDAMs or 28 small-diameter weapons. While the B-2s hit the deep bunkers, the F-15s hunt the mobile targets. Their ADSA radars scan the ground for ballistic missile launchers hiding in valleys. Working in pairs, they drop precision bombs on missile convoys, hangars, and secondary command nodes. Once they are Winchester, out of ammo, or low on fuel, they don't go home yet. They connect to this tanker common launch tube that fits into almost any aircraft's existing fuel hatch. They retreat to those tanker tracks established in Phase 1, taking on thousands of pounds of jet fuel in midair before turning back for a second sortie. 2 hours pass each hour. To sustain the pressure, the U.S. Navy's floating air bases enter the fight. Cruising in the Arabian Sea, a carrier strike group turns into the wind. Steam and electromagnetic catapults begin launching aircraft every 30 seconds. F/A-18 Super Hornets launch carrying anti-radiation missiles. Their job is DAD, destruction of enemy air defenses. They are hunting down any surviving radar operators foolish enough to turn their systems on. Meanwhile, F-35 Sea Lightning push forward to gather intelligence and strike high-threat targets that the older jets cannot reach. Orbiting far behind them are the E-2D Hawkeyes, the quarterbacks in the sky, managing the massive traffic of hundreds of U.S. jets. By sunrise, the first wave is over. The eyes of the enemy air defense have been blinded by Tomahawks. The heart of the nuclear program has been crushed by B-2s, and the limbs of the missile forces have been severed by F-15 and carrier aircraft.